In this nutshell, you will write the code for the transmitter and receiver of a remote light control using a structure diagram. And if you find this video useful, please like and subscribe. You are to write the code for a remote light controller, and the controller sends commands to a light unit, telling the light unit to turn the light either on or off. Our inputs are an on button on pin H4, an off button on pin H7, and we're using USART 2 transmitter to communicate. So the USART 0 port interfaces to a Bluetooth, and we're using the Bluetooth to communicate from the controller to the light unit. If the on button is pushed, the controller will transmit the character A. If the off button is pushed, the controller transmits the character D. Now, pause the video and write the pseudocode and the structure diagram for this problem. So when writing the code for this problem, we first write the pseudocode and then the structure diagram. So in the pseudocode, we set up the USART, the GPIO. If the light on button is pushed, first we should wait for the transmit buffer to become empty before we send anything. Then we send the character A, and in ASCII, A is 0x41. Alternatively, if the light off button is pushed, once again we wait for the transmit buffer to become empty, and then we send the character D, which in ASCII is 0x44. So we can see our structure diagram here. We set up our ports. We have a while one, an endless loop. If the on button is pushed, if that's true, we do a while loop, wait for the transmit buffer to become empty, then we transmit A. If the off button is pushed, we have another while loop, wait for the transmit buffer to become empty, and then transmit D. So now, pause the video and try to write the code using the structure diagram as a blueprint. So here is the code written from the structure diagram. I will go through the register settings shortly, but just looking at this, we define the transmit buffer empty flag, we define the inputs for the light on button and light off button, we have our setup where we configure the USART and the GPIO, we have a while one. If the light button is pushed, then we wait for the transmit buffer to become empty. So we've got a semicolon here showing that we're doing nothing here in the while loop but waiting. When it's empty, we load A into UDR2. Similarly, if the light off button is pushed, we wait for the transmit buffer to become empty, and then we load D into UDR2. So first, looking at the transmit buffer empty define statement, we are looking at the UCSRnA register, and we're looking at bit 5, the data register is empty. Now I could have put 5 in here, but the Microchip Studio has defined this as 5 anyway, so we can use the same name as in the datasheet. So now we want to set up the baud rate registers. Firstly, we can look at the table shown here, but we don't actually have the 600 in the table. So now we must use this formula shown here. So here's a formula, our crystal clock divided by 16 times by the baud rate minus 1. This gives us 832, which in hex is 0x0340. So we must break that over 2 bytes. So we put 40 in the lower byte and 03 in the high byte. Now looking at the UCSRnA register. The first bits 7, 6 and 5 are used for the interrupts, so we don't need to worry about those. Bit 4 is the power for the receiver, and finally bit 3, this bit here, is used for the transmit power, so we turn that on. Bit 2 is used for the data size, that will be 0, and we don't worry about bit 1 and 0 for 7-bit communication. So finally we are looking at the setup for UCSR2C. This is the register shown here. So bit 7 and 6 are used to select the mode of operation, shown here. So those 2 bits are 0. And that gives us asynchronous operation. Next we wanted odd parity. Now these are the parity bits here, bit 5 and bit 4. We look in this table and that should be 1, 1 for odd parity. And we can see we have set these bits for 1, 1. The next bit, bit 3, is the stop bit. We want 1 stop bit, so that bit there should be 0, shown here. And then finally we wanted 7 data bits, so therefore 1, 0 are those ones shown here. So we have 1, 0 shown here. So that's how we can configure the USART C control register for this mode of operation. And finally, looking at the data direction H register, we have the inputs are on pin H4 and 7, so they are 0 for an input. But our transmitter actually goes out pin 1 of PH, the port H, so therefore we must set that data direction bit to A1. For the second part of this problem, you are now going to look at the code for a light unit that toggles a light on or off based on commands received from a remote light controller. The light unit uses USART2, which is connected to a Bluetooth module that communicates with the remote controller. So when the unit receives a character A, it should turn the light on. When the unit receives a character D, it should turn the light off. So we can see that the inputs are the USART2 receiver. The output is a light on port B6. And this is the same format as the previous problem. Parity is odd, 7 data bits, 1 stop bit, baud rate of 600. So now pause the video and attempt to write both the pseudocode and the structure diagram for this problem. So when solving a software problem, it's best to look at some pseudocode to give some ideas about what you're going to do. So we need to set up the USART and the general purpose input output. We always have a while one loop. We are going to check the receive buffer to see if new data is received. If it is, now we need to store the data straight away, because once you read the receive buffer once, it's automatically cleared. So we can see we're going to read it twice here, which means we're not going to get the correct data unless we store it. So then we say if the received data is A, we turn the light on. If the received data is D, turn the light off. So putting it into a structure diagram, we have our start to end, set up ports, the function, and we set up the USART and the general purpose I/O. We have a while one loop here. If new data is received, if that's true, we store the data. And if the data is equal to A, we turn the light on. If the data is equal to D, we turn the light off. Now pause the video and try and write the C code from the structure diagram. You can either write it by hand or try Microchip Studio, which is free. We can see the code written here. First off, we define receive buffer full, which is looking at the UCSR2A register and it's looking at the receive complete flag. Secondly, we're looking at the light on, light off, which is on port B, bit 6. We go through, we do the main, the setup. I'll look at that shortly. So if the receive buffer is full, if we have received data, first of all we store the data in a variable. Then we're going to check if the data is equal to A. Now, we've got quotes here because A is not a variable. A is an ASCII value, it's a character. That's why that's in quotes. So if it's A, we turn the light on. Then we check to see if it was a D. If it's a D, the light goes off. And then we go and repeat the structure. And I'll look at the setup here in a second. So firstly, looking at this define statement here, we are looking at the USART control and status register A. And we are looking at the receive buffer. So we are using RxC2. Now this has been defined in Microchip Studio as 7. If you wanted to, you could replace that with 7 rather than using this statement here. But this is simply looking at the receive buffer full flag. So now in the setup, we are looking at the baud rate registers. We're doing 600 baud. So the first thing is just check the table to see if there is a figure for that. So looking at the table I have here, this is from the data sheet. They only go down to 2400 baud. So we have to use the formula shown here to work out what the baud rate registers will be for 600 baud. So there's a formula there from that table, and we can see that the result is 832 or 0x0340. So now you need to load this, put this in hex and store the lower byte into the lower register of the UBBRnH registers, and 0x03 goes into the high byte of that register. So looking at the control and status register B, we can see the register shown here. Bits 7, 6 and 5 are used for interrupt enables. We're not using interrupts, so they are 0. Bit 4 powers on the receiver. We are using the receiver, so that's powered on. Bit 3 is a transmitter, which we're not using, so that's off. And these bits here are used in 9 data bit transmission, so they aren't used. Now looking at the control and status register C. This is it shown here. So the bits are bits 7 and 6 are used to select the mode of operation. We have asynchronous USART, so we want to set those bits to 0, 0 as shown here. Next, we are going to set up the parities, so that's bit 5 and bit 4. We want odd parity, so that should be 1, 1. So we can see that's 1, 1 here. Bit 3 is the number of stop bits. We want just 1 stop bit, so that bit should be 0. And finally, we want 7 data bits, looking at these 2 lower bits here. N1 and N0, we can see that that should be 1, 0 for the 7 bits. 1, 0 here. The final bit is only used for clock polarity in synchronous mode. We don't worry about that. And finally, the light is on port B, bit 6, so we need to set that bit for output. The megaPro board has a feature where we are able to switch the output of the USART transmitter back into the input of the USART receiver, and that's controlled by a digital switch connected to port H2. So we are doing the same code, except I'm going to have both the transmit and receive code in one piece of code. The only difference here in our code is I am also looking at what I'm receiving and outputting it onto the LEDs so that we can see the LEDs and what's happening. Just to recap, this if on button pushed, and we are waiting for the transmit buffer to become empty, and we're not executing any code in that while loop. That's shown here while the transmit buffer is not empty, and we have the end of the line here. If we just go back and remember about while loops, they have the while loop and we have the opening and closing braces that show beginning and end of the statement. However, if you don't use braces, only the next line of code is included in the while statement. Shown here, there's no code being executed. So coming back down to here, that's the example we're showing here. It's simply waiting for the transmit buffer to become empty, not executing any code. So I have written that into Microchip Studio. We can download it to the megaPro board and we can see that running. So this is the on button on the remote. If I push it, the light on the light unit goes on. If I push the remote button off, then the light goes off. So we are combining both the transmitter and the receiver in the same board, and we're simply using the loopback feature on the micro to send the transmitted data back to the receiver.